everyone, welcome back to your learning spot. In today's video, we are going to break down one of the most essential concept in mathematics, sequence. What is a sequence? A sequence is a collection of terms that is arranged in a specific order where each term is obtained according to a rule. There are many types of sequence, but in this video, we are going to learn about arithmetic sequence. Arithmetic sequence. Arithmetic sequence is an ordered set of numbers that have a common difference between each term. If we add or subtract the same number each time to make a sequence, it is an arithmetic sequence. Let's see with the help of an example. In the sequence, we have 4, 7, 10, 13, and 16. The difference between each term is positive 3. So we add on 3 to form a sequence. Let's see another example. Here we have sequence of 5, 4, 3, 2, 1. So in this sequence, we have been subtracting 1 from each term to form a sequence. Now let us see what is the sequence rule to find the term. We use the nth term of a sequence to work out on a particular term in the sequence. By substituting in the number of the terms we want to find an n, we can generate a specific terms in the sequence. A term-to-term rule. In the following sequence, the term-to-term rule is plus 5. And the first term we have is 7. So it is written that in the Tn notation, let's say our T1 is 5. My T2, my term 2 is T1 plus 5. My T3 is T2 plus 5. Whereas my T4 is term 3 plus 5. So when I take my T2, it would be 7 plus 5, that is 12, whereas it will be 12 plus 5, that is 17 for the T3, and for T4, 17 plus 5 is equals to 22. So this is how the term-to-term rule is written. So basically, Tn over here is the nth term. So we can say that Tn plus 1 is after the nth term. This is the term that is after the nth term. What is the nth term? So the term-to-term rule gives us the n plus 1 term that is called the nth term. Now the Tn plus 1 give us the term Tn. Okay, so the term is known and the next one can be worked out. The link between the one term An with the Tn and the next term Tn plus 1. This is how you can add. So the term-to-term rule is Tn plus 1. With a linear sequence, the rule of nth term can be deducted by looking at the common difference. For example, let's take a sequence. 1, 5, 9, 13, and 17. This is my sequence. Can you identify the difference over here? The difference is of 4, positive 4. The difference is positive 4. So can you give me the nth term over here? The nth term will be 4n minus 3. Let us take the next sequence 7, 9, 11, 13, and 15. Can you tell me what is the common difference between them all? It is, yes, positive 2. So what is the nth term? The nth term over here is 2n plus 5. Look at the next sequence. Can you tell me 12, 9, 6, 3, and 0? Can you tell me the common difference between all? Yes, it is negative 3. It is negative 3. So what is the nth term? The nth term is negative 3n plus 15. Now, can you tell me what is the common difference? Yes, the common difference is negative 3, and this negative 3 is a coefficient of n. That means that negative 3 is being multiplied with n, and this consonant that is worked out by calculating the number needed for the term. Let's try an example question. For each of the following sequence, you have to give the next two terms. Let's try first sequence. It is 4, 7, 10, 13, and 16. Can you tell me the next two terms? Yes. Can you first identify what is the common difference? Yes, the common difference is of positive 3. So can you tell me the next two terms? It would be 19. Common difference is positive 3. So when we have the last term, we'll add the positive 3 in order to get the next number, that is 19. And again, we are going to add the positive 3, we'll get 22. Can you give an expression for the nth term? So the nth term over here is 3n plus 1. Can you write the next term, that is 5, 9, 13, 17 and 21 of the next expression? First, let us identify what is the common difference between all. Yes, it is positive 4. So what would be the next two terms? It would be 25 and 29. Okay, the next is, can you give the nth term? Yes, it is very easy. It is 4n plus 1. See, let's see how did we got our consonant. So when we take our term 2, for example, if we take our term 2, so it would be tn, 4n plus 1. So 4 into n, that is second term, plus 1. So it is 4 times 2 is 8 and 8 plus 1 is 9. So that is how we got our consonant 1. We are just going to see if the common difference and how many numbers we have to get in order to get that term. A sequence is given by term to term rule, whereas tn plus 1 is given as tn plus 3. Okay, now the t1 is given as 0. You have to find the t2, t3 and t4. So it is very easy. You just have to take the term and add 3. So the first term was 0, so we are going to add the first term t1 plus the common difference. Okay, so it would be 0 plus 3, we get it as 3. We take term 2, that is 3 plus the common difference, that becomes 6. We take the terms 3, t3 plus common difference, that would become 6 plus 3, that is 9. So we have got a sequence, that is 0, 3, 6 and 9. Can you calculate the term required and generate a sequence? Okay, if tn plus 1 is given as tn plus 5, okay, and the first term is given as 2, can you calculate t2, t3 and t4? Yes, it's very easy. You just have to add the common difference with the first term. So 2 plus 5, that would be 7. Then you have to add the second term with the common difference 5, that is 12. And then the third term you have to add 12 plus 5, the common difference, so you get 17. So the sequence we have formed over here is 2, 7, 12, 17. Can you try one more question? Yes. tn plus 1 is equals to tn minus 3. The first term over here is given as t1 is given as 4. t1 is equals to 4. You have to find the t2, t3 and t4. So you have to take negative 3, the term 1 minus 3, you get 1. The term 2 minus 3, you get minus 2. And then negative 2 minus 3, you get negative 5. So the sequence we have formed here is 4, 1 minus 2. Thanks for watching. Do not forget to check out my other videos on sequence, and for more maths topics, have a great day.